Dear students, today we will discuss estimation of solar radiation for different climatic conditions. So, before we start our today's discussion, let us summarize what we have discussed in the last class. So, in the last class we have studied different angles and then how this angle of incidence theta is related with different angles like declination, latitude, then tilt, then surface azimuth angle and hour angle. And we have developed this expression for theta. So, as you can see, this theta is a function of different angles. And for calculation of omega, that is hour angle, we have to understand how this local apparent time can be calculated. Once we calculate this local apparent time, then only we can calculate what is omega. So, that also we have discussed, and we have discussed sun path diagram, how sun travels in the sky from the observer and how this variation takes place in case of summer, in case of winter and in case of equinox. And we have studied the solar radiation geometry for horizontal as well as vertical or tilted surfaces. Also we have estimated the day length by using the calculations, and we have solved numerical problems to strengthen our understanding. So, in today's lecture we will concentrate on estimation of solar radiation under different climatic conditions. Primarily we will emphasize the monthly average of daily global radiation estimation. So, now before we start the empirical relationships or correlations, we must know why this kind of correlations are very important. The first thing, why we need empirical equations for predicting the availability of solar radiation. So, if we have enough solar radiation data by using some kind of devices, then it is well and good, then we can straightway use those data for calculations. If this data is not available for a particular location, so where we are targeting to do the calculations, then we will look for some kind of places which is having similar climatic conditions and geographical conditions. So, if this criteria is also not meeting, then we will look for correlations which can give approximate values of the targeted value of the radiation. And sometimes what happens, even though we have solar radiation data, we cannot take straightway because our requirement will be something else. For example, suppose if we get a data from some sources and that is maybe daily variation of global radiations. So, it might show even that I need hourly variation of global radiation. So, for that we need to do something, and sometimes what happens, we have global radiation, but we need to know the percentage of diffuse radiation and percentage of normal radiation in the global radiation. So, in order to calculate those parameters, we need to depend on some kind of correlations which relates the radiation data and other meteorological data, something like sunshine hours, cloud cover and precipitations. So, that way we can develop some kind of correlations to estimate solar radiation data for a particular location. And these correlations, what is developed so far by the researchers, these are not the unique correlations. We cannot use a single correlations for all the cases or all the places. So, there is a need of development of correlation for a specific locations, so that accurate estimation of radiation can be done. So, we need to have different correlations for different climatic conditions, and that too again cloudless sky, that is clear sky, and again cloudy skies. Okay. So, there are many correlations for estimating the radiation under these different climatic conditions. Also, some of the researcher claims that we can classify the weather in a different classes like clear day, hazy day, that may be fully hazy, hazy and cloudy, that is partially, and that may be cloudy days, that is fully cloudy. So, that defines this weather can be classified based on the percentage of diffuse radiation in global radiation. Okay. So, if we represent the diffuse radiation is HD in a day and global radiation is Hg in a day, if it is less than, this ratio is less than 0.25, then we can say it is a clear day or clear sky. Okay. No cloud is there. At the same time, we need to concentrate about the timing, and timing has to be greater than 9 hours, that is sunshine hour. Sunshine hour has to be more than 9 hours. So, under that condition we can consider the day is clear day or cloudless sky. And for hazy day, this ratio is in between 0.25 and 0.5, and sorry, this hour should be here. So, this timing or say sunshine hour should be in between 7 and 9 hours. Accordingly, for hazy and cloudy day, this ratio is in between 0.5 to 0.75, and this day length or sunshine hour is in between 5 to 7 hours. And for cloudy day, which is fully cloudy, so this ratio has to be greater than or equal to 0.75, and this timing sunshine hour is less than 5 hours. So, under that condition we can have different correlations. So, for the time being what we said, we will classify this as a cloudy day, and this we can say clear sky or clear day, no cloud is there. Okay. First, let us study the correlations developed for estimation of monthly average of global radiation for cloudy days. So, there are different correlations as I have discussed, like monthly average daily global radiation. Sometimes researchers are required to know for calculation of solar estimations or say solar device installations, that what is the monthly average of daily global radiation. Then in the second case, monthly average of daily diffuse radiation, and third case may be monthly average of hourly global radiation, and fourth case may be monthly average of hourly diffuse radiation. So, we will study all the 4 cases. So, let us first consider the first case, monthly average of daily global radiation estimation. So, there are many correlations developed for estimation of monthly average of daily global radiations. Among the different correlations, this correlation is developed by Angstrom, which is found to be very accurate correlation, and this is applied to many of the big cities in the globe as well as different cities of India. And here what are terminologies used? So, Hg, where we need to calculate the monthly average of daily global radiation, and Hc is monthly average of daily global radiations on a clear sky or cloudless day, okay, which is completely sunny days. Okay. And these A and B are fitting coefficients, and S is the sunshine hour and S max is the maximum sunshine hour. Okay. So, this Hc, it is very difficult to define what is clear sky. So, this is monthly average. So, I will write Hc first. monthly average of daily global radiation on a clear day, okay, and these are kilojoule per meter square per day. If I say day, it will be day. Okay. So, as I said, this is very difficult to define what represents clear day. So, normally this is replaced by H naught bar. This is nothing but monthly average of daily extraterrestrial region, on the particular day. Okay. So, this unit is also same, kilojoule per meter square per day. Okay. So, how to calculate this? This is important. So, we will derive the expression for calculation of H naught bar. How this H naught bar can be calculated? Okay. So, this is for extraterrestrial region, and as I said, A and B are fitting coefficient. So, how this is calculated? By using this radiation Hg bar data and S bar data. So, by using this data, these two coefficients or regression coefficients are calculated. Okay. So, now let us derive the expression for H naught bar. Hg bar to H naught bar is equal to A plus B into S bar to the S max bar. As you know that these are measured parameters Hg bar and S bar. So, this H naught bar and S max bar need to be calculated. Now, let us see the procedure how this H naught bar can be calculated or estimated. This H naught bar is for a representative day. Okay. So, if as we are aware that no H naught is something like radiation in the extraterrestrial region. Okay. So, as we know this EXT, that is extraterrestrial region, is equal to ISC is multiplied by 1 plus 0.033 cos of 360 N to 365. So, this will be in kilowatt per meter square. Okay. So, this expression already you are familiar with. Okay. Why this 0.033 is present here, all the informations are known to you now. So, now if I am interested on a horizontal surface, what is the extraterrestrial radiation? So, for this case what happens for extraterrestrial region on a horizontal surface, it will be EX